Hello everybody. In this video I'm going to show how you can leverage AWS Lambda functions as well as Python's Pandas library to churn through pretty massive data sets and clean them up, potentially also extract and transform them. So I guess the basic prerequisites for following along are that you have some familiarity with AWS, that you've seen the Pandas library before, you're aware that what it does, that you know how to use a GitHub repository, and potentially that you've used maybe Jupyter Notebooks or the Jupyter Lab a little bit in the past. So I will also say that the premise or the inspiration for this is that I recently had to build out a data warehouse and churn through many terabytes of data, and this data was collected through forms and other ways, and it was pretty obvious early on that there was not very good validation. Fields were in the wrong place, some fat finger errors, dozens and dozens of date formats, so things like that. So sometimes things were in the wrong column, sometimes it wasn't present, certain combinations of columns wouldn't be allowed, things like this. So not necessarily an ETL job, but more of like a scrub, extract and transform. So I came up with this generic framework or solution to processing large amounts of data very quickly and relatively cheaply using this combination of tools. So without further ado, I'll show you how you can do this. Alright, so we're going to do all of our development from within AWS, a notebook that we launch inside our infrastructure. But in order to launch our infrastructure, we need a YAML file from our GitHub. So just download that or clone it into some directory. Put mine here. Okay. Now we need this YAML file. So once you have that, then on your AWS console, head over to CloudFormation. And if you're not familiar with CloudFormation, it's basically infrastructure as code. So we can define all the things that we need and through a YAML file or a JSON file, and then it'll create that stack for us. So also, if your CloudFormation doesn't look like this, it's the newer version, you'll probably see a link up here somewhere that says like use the new one. So click on that and yours will look like this. So the first thing you want to do is create the stack. And we could just upload it, but if you want to see some details, then it's useful to look at the designer sometimes. So go into the designer, then say open local file, and get your YAML file. So you'll see all the things that we're about to create, and we'll go through them quickly so you understand what's going on. If you click on one, it'll take you into the code where it is, but this is kind of an auto-generated map of what we're creating. Alright, so if you notice, there's several sections in our definition file here. So parameters are things that we're going to input and set to default values here. So when we launch this script, it'll ask you for these, and we'll see those later. Metadata is just how it's presented to you. The important parts are really under the resources. So the things that we need in order to scrub our data and not ETL, but ET it, are in here. So first we're going to have a S3 bucket, and that's going to be the name that we import up here, or we insert. And that's basically just somewhere where we can put kind of any amount of data that we want. And once we have it in there, our notebook is going to be launched within AWS, so it'll be super fast. We can transfer things around there very quickly. But in order to do this, first we need to create a VPC. And the VPC is basically sort of a definition of a mini network that we have within AWS. So you define that, and then any resources that you launch, you can launch within that VPC, and then define how you want them to be allowed to or not allowed to communicate with each other. So this creates sort of an IP range for everything in our VPC, and then you have a subnet, and a subnet is associated with availability zone within a region. So up here we're launching everything in Ohio, so the Ohio region of AWS, and then we're saying give me a subnet, which is one of the availability zones within that region, and we'll give it a name and stuff. We create an internet gateway which allows our VPC to access the internet. We'll attach that to our VPC, a route table. So a subnet can have a route table associated with it, and then that's how you link up the resources and let them communicate with each other. So we create our route table, and then we assign some things to it. And we'll see these things after they've been created, but this is just the definition. So in this route table, the destination, this means anything that isn't explicitly defined is going to be routed to the internet gateway. And we'll associate that there. And then we're going to create a security group as well. And we need this for our notebook, but this is just a default one, and it's going to reference itself. So any instance that you attach to a security group, you can have multiple instances attached to the same one. They'll by default be able to communicate with each other because of this. And one final thing that we're going to do is create an S3 endpoint. So normally, if your instances or things within the VPC wanted to connect to S3, which is where we're creating our bucket, then they would have to go out through the internet. But the endpoint allows you to bypass that and access it directly if your instances are launched within the same region of the VPC. So that configures that for us. So we'll have pretty fast connection to all of our data from within our notebook, which is able to access that endpoint because everything's going to be in the VPC. Alright, so the next thing we want to configure is Lambda. So we're going to create a function that's going to process our data for us, but pretty much in general, with any resources you launch in AWS, by default they can't really access anything. So you have to set up a role, and that's an IAM, that defines what it's allowed to do. So the first thing we'll do is create a role and give it a name and call it the Lambda scrub data role. And we'll say we want Lambda to assume this role when we launch it. So any instance of the function is going to be assigned this role. And then a role can have policies, and the policies define what that role is allowed to do. So Lambda does a few things, or we want it to do a few things. Primarily, we want it to be able to generate logs so we can see if any errors occurred when our function is running. So we're saying allow it to create logs, log streams, events, and then write them. So this is just like a string join, and that's where the logs are going to go. So in the region that we're in, my account ID, and then a log group, and we'll see more about that later when we actually run the functions. And then also we want it to be able to do whatever it wants within the S3 bucket that we created that's going to have all of our data in it. So this is just saying it can do anything in S3, but only in my buckets. So that's pretty much it for Lambda. The actual function we're going to define later in Cloud 9. So Cloud9 is just a IDE that's online, and we can go in there, we can create a Lambda function, we can test it, make sure it does what we want it to do, and then deploy it, and then run it as many times as we want through our notebook. And down here we're attaching this policy to this role. So that's pretty much it for the Lambda for now. And then we're going to define some SageMaker resources. So SageMaker is like the machine learning area of AWS, where you can build models and test them, deploy them, train them, those kind of things. However, we're not actually going to use any machine learning aspects of it, but one of the other aspects of SageMaker is that it allows you to have notebooks, so Jupyter Notebooks. And these are pre-configured with Conda, so you have lots of different Conda environments in there for different development tasks. But specifically, it has just a plain vanilla Python 3 Conda environment for us. And that's what we want, so we can do all the things that we want to do. And so that's what we're going to do here. So just like Lambda, we have to define a role and say what our notebook is allowed to do. So basically we want to allow our notebook to access the S3 bucket that we created, as well as, which is here, so we want to list our buckets. We want it to have access to the bucket we're creating above, and we also want it to be able to know about Lambda functions that we've built. So we're going to say we can list the functions that we have, invoke a function, get the details on it. So that's what we're saying it can do there. Now also, whenever you launch a SageMaker notebook, you're getting a clean instance. So any changes you make to the instance are going to be forgotten every time you start it. The only thing that remains is whatever storage that you assign to it. So you can assign up to 16 terabytes of storage to any particular notebook, and that will remain. So anything you put in there will be there. But anything else, you need to establish at the beginning yourself, or automate it by having this script here. So that's called a lifecycle config, and basically we're saying run this script anytime it starts. So the two things you want to see here, you may or may not need this, but it's a different zipping facility. I've run into problems where I'm dealing with zip files that are in a format that the native unzip or gunzip in Linux can't handle. So I usually like to install the P7 zip to handle those scenarios. And then in here, we're going to be using the Python 3 environment, and the Pandas library in there is old. So I'm going to be installing a newer one every time I launch a notebook instance, and as well as a newer version of S3FS. So that's installing all of those things into the Python 3 environment, and it's doing it in the background. So there's a time limit on how long these can run, and sometimes the Conda takes a while to resolve the environment, so I'm doing this in the background using the NoHub. And those things will be ready for us when the notebook launches. And finally, we're going to define the actual notebook. So all of that's here, and it's linked to the lifecycle config that we just made, to the execution role that lets it access Lambda and our S3 bucket, and the name that we defined as a parameter at the top, which we're going to enter when we launch the script. And then we're going to say launch it within my VPC. So you give it the subnet and the security group, and we're going to also give it 10 gigabytes of disk space. So this particular instance, it's got a fast network connection, and I think 4 virtual CPUs, 16 gigs of RAM. So it's good enough for what we need it to do. We can go much larger. I think it's like 27 cents an hour for this one, and 10 gigabytes of space would be like $1 a month or something like that. And so that's it for SageMaker. And once this launches, we'll have a notebook we can do all of our development in, other than creating the Lambda function. So that's where Cloud9 comes in, or basically saying give me an IDE environment, and launch it with this machine size. So this is like 10 cents an hour. It's not very powerful, but Lambda functions can't have that much RAM or computing capacity, so you don't really need a huge machine for this. And we're also saying if we haven't used it for 30 minutes, shut it down so you don't get billed. But so yeah, so if you don't use it, you get charged 5 cents and it'll turn off. And that's pretty much it. The outputs are just like useful information about the things that we just created, and we'll see those when we launch the script. So now that you know everything we're launching, which might seem like a lot, but once we look at it, it'll make a little bit more sense. So when you're happy with that, then you can say validate the template. It'll make sure that your YAML is configured properly. And then if you like that, you can go to create stack. Okay, so once you're in create stack, it's automatically going to have it there for you. And you can just say next. And this is maybe the one tricky part. So we'll call this big data scrub. So your S3 buckets, they have to be unique across like all of S3. So to make sure that they are, I've already opened it here, but you can go there and open up your S3. So what I'd recommend doing is creating a bucket, like I'll call mine Chi-Town Data Scrub, or Chi-Town Scrub Data maybe. And I'll try to create it. If it works, then you're fine. So just delete that after you make it. That way you know your script is not going to fail. And then put that in here. So find a name that works for you. And then SageMaker, this is what we're going to call our notebook. Cloud9, we'll just give the environment a name so we know what we're doing in there. And then just click next. And next. And down here, you want to say, yeah, I agree, you can create IAM resources. And that's it for the stack. So now you'll see the stack is going. And if you do events, you'll see it going. So that'll take probably like 5 minutes, and when it's done, we'll have everything we need to start processing our data. Alright, so it looks like everything's done. We got complete. You might notice also that an extra stack was created. So this is our Cloud9. It makes that automatically, so it creates the instance and stuff for us. But in here, you have your resources, events, resources. So this is everything we created that was defined in our YAML file. And we'll look at a couple of these in a second. And the outputs was just things that we wanted to see. So we've got our bucket name, the role names, and we'll see those again. So before we launch our notebook, I think we should look really quickly at our VPC and our IAMs. So open up a couple of these. If you type in VPC, then you'll be able to see what we just made. So my VPCs, this is the one, the data scrub, we called it. You can click on that and you'll see, kind of see how things are wired together. So we've got the VPC, is our route table. So we've got a subnet that's associated with that VPC that we named. The route table. So this is for communicating amongst things inside the VPC. This is our endpoint to S3, so we don't have to go to the internet. And everything else gets routed to the internet. So IPs that we don't know. The gateway we made is attached to our VPC. The endpoint to S3 definition. Security group. So we've got our security group. And that's about it in there. So you can look through that more, but that's the gist. Then in here we want to go to IAM, and we'll see the roles that define what various things can do. So we've got our Lambda role that we'll assign to our Lambda function when we make it, and you'll be able to see what it's allowed to do. It can create the logs, and it can access this bucket that we made. The other one, the SageMaker, this one can do a little bit more. It can access those buckets and also access Lambda and invoke a Lambda function. So that's it for that. Then now we can just get started in SageMaker. So we'll go over here, say Sage. We have our lifestyle config, our notebook instance. If you click on that, it'll give you, there's the instance we wanted. Here's the role that lets it access our S3 and stuff. It's in our VPC. And then CloudFormation also keeps track of things so we can delete them easily later. And we got 10 gigs. So we got 10 gigs to work with. And it's already launched it for us. So I would suggest using Jupyter Lab. If you're familiar with Jupyter, you're going to like Jupyter Lab even better if you haven't used it yet. So open that up. And once that loads, the first thing I usually like to do is go in and do the dark theme. Easier on my eyes. And once we're there, then we can get started with processing our data, or at least figuring out how to get our data, break it up into chunks, and then process a single chunk, and then convert that logic into a Lambda function so we can process all of the chunks. Alright, so this is the basic interface for the AWS hosted notebooks in SageMaker. So all kinds of environments, but mainly we're interested in like the Python 3 one. But the first thing we want to do is clone our library because it has all of the notebooks that we want. So we'll clone that. Okie, refresh. And that'll have our books in there. So the first one you want to open is the data management. So make sure that you're using the Python 3 kernel, because that's where we installed the latest Panda, or not latest, but a newer Pandas and S3FS. And the first thing we want to do is get our data. So you can already just jump in, start running the cells. So that's there, and then you can go down, get some logs. It's going to create some logs for us, and then right away we're going to start downloading our dataset. So you can just fire that off, and it's going to download it in there, and that'll probably take like 5 minutes. So in the meantime, you can look at the data that we're using. So it's basically Chicago crime data for the last almost 20 years. And it includes everything other than murders, I guess. But in the last 20 years, been around 7 million crimes in Chicago, and pretty interesting data in there. So why did I choose this one? It's surprisingly difficult to find a very large and messy data set like the one that inspired this video, but I figured if I was going to find something, it would probably be in government data, and so I started looking around data.gov, and then I stumbled on this one. It's not as big as I wanted, it's only 2 gigs, but there's enough variety in the data and enough sort of use cases where we can examine how to kind of scrub it, extract and transform some things from the data, so you get an idea of how you can use Pandas to clean your data. So once this is done, then we'll come back here and continue on. Alright, so we finally got our data, and that'll be in here again. And it's only 2 gigs, so you could do this in memory, but you need to pretend that we've got a lot of data. It's too big for memory, and we want to break it into chunks so we can work on the chunks, figure out how to process them, and then put it into Lambda to do all of them at once. So next thing we want to do is split the files up. So there is a utility library here, and there's a split file function in there, and by default it's going to split them into 1,000,000 rows in each file. So you can start that. And basically I chose 1,000,000 just because some people use Excel, and that's the max rows you can have, and it's easy to look at in something like that. But if that's not like a constraint for you, you can just kind of test breaking them up and break them into reasonable sizes. So maybe 100 megs up to a gig or something. So Lambda can only have 3 gigs of memory, and can only run for 15 minutes. So you kind of want to choose your file sizes according to that. Leave some room for overhead for other things that are happening, especially maybe you're copying data frames or doing things to them, and so you want to keep some room for that. But so once we have our data there, we'll see it's all split up for us. Then the next thing we want to do is upload those to our bucket. So just check in S3 again, make sure your bucket's there. So mine's there. Change the bucket name to whatever your bucket name is. And we're going to use the S3FS module, which kind of treats S3 as if it was a file system, even though it's more of like a key value store. So we can start uploading our data to our bucket now. And this should be a lot faster than downloading it because we've got a pretty fast connection within AWS. So that's one way to do it. If you actually have like a terabyte or 100 gigabytes or something, another way you can do this is through the command line, which is a little bit maybe faster, but definitely isn't prone to breaking or anything like that. I've had some problems with S3FS on larger files. So the way you do that is go back to the launcher. If you close that, then you just click this to get your launcher back, and go to the terminal, and everything's in you can see what's in here, but everything's in the SageMaker folder. So you go in there, and then so we go to Lambda data, and then you can use the command line tool. So I put it here for you, but basically you're using AWS S3 copy, and then you're saying copy my whole directory into some folder or some bucket in S3. So you could do that like this. So you'd say AWS S3 copy this directory to my bucket is Chi-Town scrub data. Then I want to say recursive, so it copies everything. We'll say dry run first, and then I'll exclude the big file that's not broken up because we don't want to process that one by itself. Or just say crime that way. And dry run means it's not going to actually do it. It'll just show us what it's going to do. So it's going to upload these 7 files into that bucket. That looks good. So you can take the dry run off. You can run that. It'll just overwrite the files. So you can see we're pretty fast, get like 150 megs a second. So if you did have a terabyte of data, you could copy it all in about an hour, which is pretty handy. So we're done in the terminal. We've got our data. Now we can open up the scrubber. So we'll open up that, and we'll also open up the data utils. and we'll look through that in a second. But now we're ready to try to figure out how to process just one file and get it pretty clean, and then we'll turn it into a Lambda function. Alright, so now we've got our data downloaded and split up into little chunks, and we need to figure out how to process just one file. And if we can do that, then we can process all of them at the same time by converting it to a Lambda function. So another useful tool in notebooks is like the auto reload. If you have some libraries that you're working on your own, like I have these helper libraries, and you can set it to reload them every time before you run a cell. So if you're in development, that can be handy. But we don't need that for now. So we'll run that. We'll set up our logs again, and then we'll scroll down and we'll start loading the data. So, and then we'll talk about those functions above. So this will connect to S3. We can see the files that we just uploaded are there, and eventually we want to process all of these. So imagine there's thousands. So what we'll do is we'll just pick the first one, and we'll load that. And important to note here is, like, when you're reading CSV and Pandas, there's tons of options you can set, but like one of them is the data type, and I'm saying just use strings for everything. If you don't do that, it'll automatically infer your data types, and you could run into problems. So like if you have integers and you have null fields combined, it'll automatically convert those to floats, so then you'll get like precisions at the end, and it can be weird. But because we're going to validate things with regular expressions, I just want the data to come in as it already is, and then we'll validate it ourselves. Then clean column names is going to convert things to lowercase and replace spaces with underscores, so it's easier to like reference things. And then extra white space, it'll trim and remove extra white space from within strings as well. So it might not make sense for some data, but it does for this. So once we have that loaded, we can take a peek at the head, or maybe up here. So let's make sure we define our regex. So some things about our data, like let's say we've analyzed it and we notice that there's id, and that should be an integer. So it looks like that. If that's not an integer, we need to exclude the row, maybe. Case number, let's say I know that the first two things should be letters, and if it's not, then somebody typed it in wrong and it's invalid. The date, it looks like they're using a consistent format, so we can define that format and try to parse it. Maybe we want to split that up into like years and months. Blocks, we've got part of the address that's obscured, so it's kind of useless. Maybe we want to extract the street name and not use this. This, maybe it should be length 4. Always. These ones we could say only should contain letters or something like that. These two should probably always be true false. And then location, looks like we have latitude and longitude, but we need to extract it. Zip codes can be 4 or 5, it looks like, but maybe we want to put a 0 at the beginning if it's 4. So these are just some possibilities of things we might want to do or validate and make sure that the correct data types are in the columns. So that's what our regex is going to do. So here we can see all these things. So like for example, location, we can copy that in and go over to our regex tester, put that in, copy in a location, and then we can see that we've got the latitude and the longitude, so we can extract those. And this one, regex 101, is pretty good because you can say Python, then you can say insensitive, and then it'll explain everything that your regex is doing over here, which is super handy when you're developing it. So that's just one possibility of thing you might run into when you're validating your data. So once we have that defined, let's define these functions. Now basically what we want to do is go through every column of our data and say these are the things we might want to do to it. So there's a function in data utils that does all of these things for us. And this is all just using pandas. So this is kind of the important part. So there's things that we might want to do. First, how do we deal with nulls or things that look like nulls? What are other things that could be a null? Pre-processing, let's say you have some words and they're combined with plus signs, but you know that a plus sign should be a space. You could pre-process and replace those. And then validation would be your regex. So I know what should be in there after the handling nulls and pre-processing. And if it doesn't match that, then we need to do something. Post-processing would be like, maybe I want to change things from all caps to like the first letter caps. Then once you have that, you might say, okay, these are my valid values. Like if you're working with states and you know all the valid states, and that could be another validation. And you might want to generate new columns, like with our location column, we want latitude and longitude. So we can do all these things using this one function. And basically these two, the process hard and soft rejects, are wiring what we want to do to each column, and just passing it to that function. So for example, here we say that id should be a number. That case number should start with 2 letters. That date, we're going to say that it's a date field, and we've defined what a date should look like, the pattern. And we also want to extract the year and the month, so we'll add those as new columns. And a hard reject is like anything where we have to exclude the entire row if it's null or the validation fails, because maybe we're importing this into a database later and it's part of our primary key, or we just have to have that field for some reason. So those would be things that are going to be excluded if they fail. It's going to exclude the entire row if this one particular column or logic fails. And then the soft ones would just be like, oh, we'll just set it to null if it fails, because we still want to keep the other data, because we have the ones that we absolutely need, but now we want to keep that row. But we'll just set this one to null if it fails for some reason. So it's the same thing as the hard rejects, it's just we're dealing with the other columns now. So maybe we want to not have caps, so we'll pass it a function that does that for us, or return it to uppercase at the end. That's fine. With the block, we're going to extract the street address and the house number into separate columns, and so on and so forth. Here, these columns have to be true or false. And you can combine logic as well. So here we're saying it has to match my regex for what a description is. Like maybe it's just letters and dashes or something, and it has to be less than or equal to 50 in length. So that's how you define that there. And then everything gets passed into process field. So now that we have all of our logic set up, we can try processing just one file and see what happens. Alright, so we can take a little peek at our data first and see what's in there. We're not really going to explore the data too much, because the purpose of this is to show how you can clean it and process it, so that you can analyze it later rather than digging into it. But there are a few things in here where you can just kind of look through and see some interesting stats, like the most common crimes and most common crime locations. So if you look here, you'll see that if you're on the street, the sidewalk, your apartment, or your residence, that's the most common places where a crime occurs, so you're not really safe anywhere. But anyway, so this is sort of the main logic that we're going to pass into our Lambda function. So we can start running that, and we'll see that the first thing we're going to do is process the hard rejects. Those are the ones that, we have to throw the rows out, but we don't want to lose track of them. We want to store them somewhere, so we can analyze them later and make sure we got it right. The same with the soft rejects. So once those two run, then it'll get passed into an analyzer and tell you like the counts for the fields that you processed. So you get an idea of what's being rejected, so you know maybe which fields you need to focus on to get them in shape. And then we'll generate some data frames on the rejects, and we'll look at those. And we're going to upload them to our S3 bucket. So when this is done, over in S3, you should be able to see some buckets now. So you have rejects for the file, the hard ones, the soft ones. These are the data frames that we're going to look at in a second. And the same with the clean data. So this is what we think is now our clean data. And once we have all of these, then we could load them into a data warehouse or analyze them in Spark or something like that. But yeah, so we tested it on one file and we saw that it looks like it's working. We can see some stats now. So we see that everything looks pretty good. There's a few case numbers that seem to be wrong, and maybe some descriptions or location descriptions that don't match our filters. So just take a quick look in there. So the hard rejects, you'll see probably 13 of those in there. So in our regex, we said that the first two letters of the case number have to be letters, or the first two things in the case number have to be letters. So here we can see that these ones don't match that, so something went wrong with those. And it's just an example, but like let's assume that those are bad for some reason. Then in the filtered data frame, we have our clean data, or what we think is clean. So we'll see the same thing in there, and those all look like they're valid. So that's promising. The same with soft rejects, but when you create these, when we process each field, the clean data is put into the original column, and then the dirty data is put into the original column if a validation fails. So anything where that's not null, that was a field that we rejected. So the same way that same kind of stats we get from analyzing them, we can see by running some more queries on the data frames. And we'll see the same numbers that we saw before. And so maybe we want to look at like the description and see, okay, what was the regex that I used? Now show me a sample of the ones that we're rejecting. So maybe it was because the length was more than 50, or there's more words than we expected, or we weren't including some type of text in here. But like, as this is just an example, and these aren't actual real filters, like this probably should stay in because the data is not actually bad, but it's just showing you that our validations are working. And you also might want to look back at your clean data, see what's in there, the fields that you plan on filtering. You might want to do samples of those columns and make sure that everything's working right. But once all that is done, now we're going to take this code and put it into a Lambda function and then run it across all of our data. Alright, so let's pop over back into here and go into Cloud9. Now you should see the IDE or the configuration for it that we made in the CloudFormation script. So just go in there. It might have to reload if your 30-minute timer ran out, because it stops the instance that hosts it automatically. You can switch to the dark theme here if you want. Then over here you'll see resources. We'll look at that in a minute. But what we want to do is create a new Lambda function, and we're going to call this scrub Chi-Town file, and we'll just call this Chi-Town scrub for the application. Select empty Python, Python 3.6, no trigger. We'll change this later, but we'll use the role that we made. That's the one that lets us access our S3 resource, and then finish that. So you'll see it created over here, and you will see a Lambda function here. So we can quickly test that by doing something like print hello world. Maybe we'll say hello Lambda. And then in preview, you could say preview my Lambda function, and then run that. Oh, maybe save it first. Run that. You should see hello world, or hello Lambda. So now you can close that. We'll go back there. But what we want to change first is in the template. We can say keep current version. What we want to change here, so if your memory size doesn't say 3008, change it to 3008. The timeout, you do want 300 seconds, so that'll be 5 minutes. It should only take a couple minutes, but so we'll just give it some breathing room. But that's the maximum time we're going to let it run. So that should be good for that. Once your file looks like that, make sure you save it. Then when you make a Lambda function, all the resources that you need have to be packaged with your function. So the first thing we'll do is upload the code. So, and then we'll import the resources that we need. So you click on the name of the application, and then what you want to do is file, upload local. So what we need is the data utils, that, and I've already copied and pasted the code into Lambda function that we want. So those are again from the GitHub repo that you cloned earlier. So we have those now, and what we want to do is replace our Lambda function, and then the next thing we want to do is again click on Chi-Town Scrub and then say open terminal here. Now we need to get the libraries that we need. So first you can see Python 3 and pip list. So these are the libraries that we have right now, and what we need is pandas and S3FS. So we'll do pip install pandas, the same ones that we were using in the Jupyter notebook. And then here you have to say target local. So this will install these dependencies into our folder structure here directly. Oh, I didn't put an extra equal sign here. Okay, let's see here. So that should be done in a second, and we should see the files coming in here. Alright, so now we've got everything we need, hopefully. And what we want to do is go back into, yes, we can close you now. Go back into our Lambda function. So this basically has the exact same code from the scrubber. Here we have the regex that we need. We are setting up the logger a little bit differently because the Lambda already has a logger, so we just want to change the format so that we can see where some of the sub-modules, where we're at when we're processing the files in those. But everything else is pretty much the same. So up here is the function that's going to get invoked when we invoked our Lambda function. And we're going to pass it an S3 bucket and an S3 key. So that will be the bucket that our files are in, and then the key to the file. So we can pass all of our files in to different Lambda functions, or copies of the same one. And then it's just going to open it, do the processing, log the rejects and stuff, and then upload them to S3 the same way we did in the Scrub notebook. So we can quickly test this by doing something like this. So comment this out, save it, go back into the preview, and here we can say like S3 bucket, and so that was Chi-Town Scrub data. So Chi-Town Scrub data, and S3 key, and so this would be, let's say, number 2. So copy that in. Now what we should expect is that it's just going to say that it's processing that file. This will also confirm that our imports are working. So like we have the AWS and data utils that are over here, and Pandas and S3FS. So all those things imported correctly, and we can access them from our function. So that's good. So if you uncomment this, now we can test it again. So we can run that, and it'll take a few minutes, but let's just assume that it works, because it does. And so what you want to do once you have your function working is over here in the AWS Resources tab. So we can actually, just in here, you want to do deploy. Now it's going to deploy that function. So while that's deploying, we can open up another tab that is, and just go to Lambda to make sure that it's there. Oops, we did make one mistake. So by default, the Lambda function name is going to be the name of the stack. So Cloud9, Chi-Town Scrub, this one, and then a bunch of other stuff. But we just want it to be named like one particular thing. So back in the template, you can say function name and call it Scrub Chi-Town file. Save that. Now let's deploy our function again. And within a minute we should see that. And I guess while that's deploying, we can, back in Jupyter Lab, go into your Lambda notebook. That's over here, so it's the third one. Alright, so that's deployed. Now we can look at it. It won't let us see the code because the file's big and it's got all its dependencies. So it'll say you can't see it, it's not available for inline editing. but it is there. It says we can deploy it. You'll see over here that we are able to access our buckets, and you also see here that it is able to write to the logs in the Lambda logs. So that looks good. And the next step is we'll go back over into SageMaker Notebook and make sure that we can access Lambda from there, and then invoke our function on all of our files and then watch them get processed. Alright, so let's head over here. We're going to open up the Lambda notebook if you haven't already, and what we're going to do now is same thing as before. Start running the cells. We'll get some logs, and first thing we want to do is connect to the Lambda services using the Boto 3, which is the Python SDK for all the AWS resources. So we called our Lambda function scrub shytown file, so let's look for that. Through the client, we can call the get function and pass out our function name, and if it has it in there, we should see the configuration. So let's see, it's like 42 megs. This is the long form resource location, and then everything that we configured. So we gave it lots of memory. That's the max. 3008 megabytes is the max. And runtime is Python 3.6. What else? Timeout 5 minutes. So it all looks good. So once again, let's go through our files. So these are the ones we want to send. So we're basically just going to loop through and invoke the functions. And if it was able to start the function, you should get back a status code of 202 when you use the invocation type event. So event means that it's going to process it asynchronously. You can also do it synchronously if you wanted to and get more results back, more detailed results back. But this is basically how you do it. So the payload has to be like just kind of a binary. And alright, let's run it. Ooh. I spelled response wrong. There we go. And there we go. So they're all sent out. And if you want to see what's going on, then we can pop back over here, open another tab, and go into CloudWatch. This is where the logs are going to go. So inside of CloudWatch, over on the left, you should see logs. You can see a log group that has our function name for the Lambda. And you'll see a bunch of stuff opened up. So these are from today. So we got 1, 2, 3, 4, 5, 6, 7, 8 things that are running right now. And you can watch them in real time. So that's processing that. And in about 2 minutes, we should have everything done there. So while that's running, one other thing is back in here in the preview. Oh, never mind, preview running. Well, I can't show it now. But in here, when you did the preview, there was a little thing after you run it that said the memory that was used. So that's a good way to know how much memory you might want to assign to your Lambda function. But so we're using the max because when I tested it, it was around like 2 to 2.5 gigs was the average memory size on various files. So that's why I set it to 3. And the reason that's important is that the way that Lambda bills you is by gigabyte seconds. So if you have 3 gigabytes and it takes 2 minutes, then you get billed for 360 seconds. It's not a huge deal. Like by default, you get 400,000 seconds per month free. So what we're doing right now is actually free. Alright, so it looks like everything's pretty much done. So here you can see it here. So milliseconds build. So 98 seconds to process that file. And to see that if everything is going well, other than looking at the logs, we can search through the logs, but just to confirm that everything looks like it's working, we can go into our files, or our folders. Maybe you have to refresh, and you should see all the rejects coming in. So the hard ones we should expect not too many, so very few of those, except for here. So that's something we should look at. Maybe some case numbers or something that didn't start with 2 letters. And then the clean data, we should also see all of our files were processed. So it took about 2 minutes, 90 seconds to 2 minutes to process all of these. And by default, you could have 1,000 lambdas running at the same time. You can request more, but so our files were 200 megabytes. If we ran 1,000 of those, we could process 200 gigabytes in 2 minutes. So if we had a terabyte of data we wanted to clean up, we could do that in 10 minutes, just using the default limits. So that's pretty cool. And that's about it. So what have we done? We've used CloudFormation to launch all of our resources, created a VPC, various IAM roles for executing things within SageMaker notebooks and Lambda functions. We created a SageMaker notebook. We did all of our coding in there, downloaded data, processed it, turned it into a Lambda, and crunched all of our data very quickly. So the only thing left to do is tear everything down. So that's what we'll do now. So when you're ready to get rid of all the resources that we made, the only thing you got to do is just close your notebook. You can leave it running, it'll still shut it down and get rid of it. The other thing is that it will fail to delete your S3 bucket if it has anything in it. So you might want to just delete everything that's in there, and then go back over to CloudFormation. So since this one was created from this one, you just need to delete the stack that we originally built, and then also delete this stack which was created by Cloud9, which just has our Lambda function in it. So if we delete that, everything should just start flowing on the deletes. And you can watch it in progress, and within maybe 60 seconds or so, everything you built will be gone. So here, alright, it's already disconnecting on us. Lambda, let's see, functions, yep, that's all gone. The logs will still be there. This environment should disappear. So that's gone. And Shitetown Scrub, let's see, that's gone. And then our notebook, it's stopping it, so that'll be gone. And once it stops the notebook, it'll be able to delete that as well. So you can check back on that later if you want, but pretty much that's it. So it's that easy when you use CloudFormation. You can just fire up what you need, use it, and then get rid of it. So thanks for taking the time to go through this with me, and I hope it's been useful to you.